Good morning, everyone. I'm Sarita Swanepoel, and today we are looking at how to prepare for the physics paper. Right, now we start off with a few general things. What you need is metacognition. Now, some of you don't know the word. Cognition is thinking, and what you need to do is you need to think about your thinking. Right, you don't just study. You have to stop and ask, do I understand this? I have to stop and check to see if I really remember the definition the way that I learned it. You must be in charge. And that's what's metacognition all about. Thinking about your thinking, right? Now, to help you with that, let's start by looking at a few questions about your exam. First off, when you study, who? Well, you and only you. I've got news for you. You can have a great study buddy. You can have the perfect teacher. You can have fantastic junior techie videos to watch. But when it gets down to it, you have to be the one to sit down and study. And also, you have to be the one to say, do I understand? Have I now made this concept my own? Can I apply this? Right, you and only you can do that. Right, next up, why? Now, this is all about motivation. If you know why you are studying it, it will help you because you are going to spend a lot of time on this. And if you are motivated, if you know why you're doing it, then that will definitely make a difference. So for some of you, that will be to get into university in a specific course that you want to do, or just to get a better job. Or some of you might think it's to impress your classmates or your parents or your girlfriend or boyfriend. Whatever your goal, try to make it long term. But if you can't, then focus on short term, but make it work for you. Make it your motivation for sitting down and really doing the work. Next up, what should you study? Now, you are going to start off with what your teacher and your textbook gave you about the cups, right? And if you need another textbook or some more information, if there's something that you don't quite understand, remember there's a free textbook, Siyavula, the free Siyavula textbook that you can go to on the internet. You just go to siyavula.com and there you can read or download the textbook and also the teacher's guide. And they are specifically written for CAPS, so they will steer you in the right direction. And especially if you have a grade 11 topic and maybe you don't even have the grade 11 textbook anymore, then you've got a problem. But the Siyavula textbook is there for you. Right, next up, exam guidelines. Now, guys, this should be lying right next to you all the time that you study because it's telling you exactly what you have to know about every single topic and what topic and how much is it counting. All of that is in there, and also how they're going to mark. So if you are doing the departmental national paper, right, you can download it from there, also on the government website. But if you are an IAB student, then please go to the IAB website and download it from there. It's very important that you really use the correct one. And even when you're watching videos or you are using another source that's not your textbook, make sure they are using the equations and the definitions that are specifically for your exam. Let's take, for instance, work. If you look at the IAB information sheet, on the IAB information sheet, there's 3 different equations and they can choose any one, right? And the definition that they have for work is they define the work done as on an object by a force as the product of the displacement and the component of the force parallel to the displacement. So that F over there is not the whole force, it is the component of the force parallel to the displacement. So when they do this and they use that first one, they will say, okay, W equals F times S, and that F is now the component of the force parallel to the displacement. And in this instance, if that was the force and that was the angle, then that would have been the X component, right? And the X component you would have worked out with F cos theta, and that would be times S, and in this instance that would be delta X, right, is our displacement. And if you rearrange this, you end up with F delta X cos theta, and now this F is not the component, that is the whole force, right? So to get the component, we use the whole force and cos theta. So they can use any of the three. But with the Department of Education, we only have this final one over there. So they tried to make it easy. They already put the cos in there that made it into the component in the direction of movement. So now that F that we use over there is not a component. That F now is the magnitude of the whole force. Right. So guys, be careful. Do I need this definition or do I need that definition? It depends if you're writing an IAB or a Department of Education paper. So make sure you have the right exam guidelines. Your exam guideline will tell you what you are supposed to give as a definition. Right. Now, when you've done a lot of studying with your exam guideline next to you, then you are ready to start working on previous exam papers, and you can download them from the Department of Education website, and I'm also going to put a link on your PDF where you can find the papers for the last few years. Right. Next up, when am I supposed to study? Well, guys, you have to make your own schedule. And for that schedule, be very specific. Don't say, I'm going to study. It's during the prelim, right? Start by being very specific. Write down a date and a time, right? So on that day, I'm going to start at that time, and I'm going to do physical science. But not that. Don't stop there. Be very specific. Don't say, I'm going to do physical science. I'm going to do projectile motion, right? Be very specific. So schedule this for a specific time and date. You are writing a 3-hour paper, so you are supposed to be able to concentrate for 3 hours, but I know during the day we are not always able to focus that long. So for me, for instance, I like to work early in the morning. I will start at 7 or 7:30 and then do maybe a 3-hour stretch until from 7:30 until 10:30, and then take half an hour break and start again, but then only do a 2-hour session. Right. So you have to decide what's working for you. And then the most important thing is don't just schedule the learning, the studying session. Also schedule the rest and the social time. Right? If you don't make time, if you don't put that on your schedule, you will feel cheated and you will always feel, I don't want to do this. But if you have that social time scheduled, then you have something to work towards. Right, and the last one is be realistic. Right? If you know you've got a difficult topic and it's taking a lot of time, don't say you're going to be able to do that in 2 hours. Right? Be very realistic. Think about it, and that's why you really have to think about the topic and then decide how much time you need. Right, moving on. Okay, so now I have scheduled the time. I am sitting down, I hope, to do this. And now the question is, how do I do this? Now, the most important thing is you have to have a pencil and a paper and you have to write. You have to check if you know the definitions, right? When you've learned the definitions, you have to check that you've got them right. Also, you have to do the questions. Don't just take a paper. I know a lot of kids who take their textbooks and then they read through the textbooks. And when they get to a question, they say, oh, it was the difficult one. Oh, but the trick was that. And then they go on. That is not the way to do this. That is not really making sure that you understand. You have to cover the question, read the answer, read the question, redo it, and really make sure that you understand what they're asking and then doing the question. Right. So write. Don't just read. Okay. And also don't rewrite the textbook. Don't write over everything in the textbook. Be very selective. For you to be metacognitive, to think about your thinking, means you have to look at the work and you have to be able to extract what is important. Right? That will mean you will think about, do I understand? What do I understand about this? Right, next up, no cell phone. I think you're going to cry now. Okay, now we have to stay in touch. I know you have to stay in touch, but when you are sitting down to work, don't have your cell phone with you. It must be on silent, switched off, and out of sight, right? But when the moment that your study session is up and you get to that rest and social time, then get up and answer your WhatsApps and send your messages and stay in touch and keep the guys informed of how you are getting along, right? So no cell phone during the studying periods, right? They will, if they are really your friends, they will understand if they have to wait 2 hours because you are focusing on your studies, right? And then reminder list. Put a little piece of paper next to you where you can write down things that you are afraid you're going to forget. Because the moment that you're going to sit down there, you're going to remember, I have to feed the dog, right? And then if you don't immediately get up and feed the dog, well, if you get up and feed the dog, you are actually not studying, right? But if you don't immediately do something about it, your brain is going to keep on having a part of your brain every now and then reminding you, oh, don't forget the dog, don't forget the dog, right? So what we do is we write it down on this little piece of paper right next to us, and now your brain will know. You won't forget it because it's written down there. So if you have to buy Susie a birthday present, write it down. If you have to call your grandma, write it down. Okay, because then you can focus on your study. Next up, stick to the schedule. If you start to cheat, then you can actually throw that schedule away, because then it's not worth anything anymore, right? You will keep cheating and you will keep changing, right? Stick to the schedule. And that's why it's very important that you have to have a very realistic schedule. Next up, test your memory and your understanding. Don't just input, right? You have to have metacognition. You have to think about your thinking. I've learned this definition now. Do I now understand it? Can I apply it? Do I have it completely memorized? Will I be able to give it back? Remember, memorization, that definitions are very important. That's 15% of your question paper will just be plain recall or remembering. And most of that are definitions. So at the end of this study notes that I gave you, I've added the definitions that the Department of Education prescribed for you in the exam guidelines. So they are the correct wording. And for the guys who've got IAB, you will just have to download that exam guideline and get it from there. Right, so do the memorization and then test yourself to make sure that you have it. If there's 2 sentences in that definition, don't leave out the second one, right? Then understanding and application, the easy and the more difficult questions, that you have to practice with old exam papers and the questions in your textbook that you've done before. And then we get to evaluating and creating. Now that's supposed to be new questions, right? You have to apply to new situations, or they're supposed to ask you something that you haven't learned, right? But for this, it will really help if you've watched that videos on maths in physics, because a lot of this will be, if I change variable A, what's going to happen to variable B, right? That type of questions. Right, but now let's focus specifically on physics. Now for physics, the first thing you have to remember is there's a lot of units that I have to convert, right? So kilometers per hour to meters per second, or microcoulombs to coulombs, or things like that. So make sure that you can work with the units. Next up, there are some of these topics that were discussed in grade 11 and not again in grade 12. So for instance, Newton's law, remember that's a grade 11 topic. And then also when you get to electricity, electrostatics was a grade 11 topic. Electromagnetism was a grade 11 topic. And electric circuits also had a grade 11 part, right? So for them, you have to go back to either your grade 11 textbook or your grade 11 file. After that, we're thinking about all the things in mechanics. Now, when you get to mechanics, guys, with mechanics, there's definitely going to be forces involved here. And for the forces, I really want to recommend that you draw force diagrams, 3-body diagrams, right? So do the 3-body diagram, even if they don't ask it, even if it's not for marks, right? Still, for all of them, draw the 3-body diagram so that it will remind you what forces are present and how would I use them in the solving of that problems. So make sure that you do that. And after that, we get to the Doppler effect. Now, guys, Doppler effect, I can't stress enough. Doppler effect, 17%, right? So 17%, that is 17 marks, that's 11% of the question paper. You can't skip the Doppler effect. You really have to do it. And I would focus on Doppler, make sure you know all the definitions, and then go and do a lot of old questions so that you are sure that you have that 17 marks in the bag. Right, moving on. When you get to electrostatics, that's plain grade 11, right? Coulomb forces and also electric fields. So go back and study that. And often you haven't repeated it in grade 12. So start with that so that if you've got problems, you still have time to go back, right? Electromagnetism, also grade 11, right? But here, what's important is you need to know calculations, right? When you were in grade 11, you did Faraday's law, and for matric, you have to know Faraday's law, and you have to be able to apply that to motors and generators, but they are not going to ask you for calculations, right? Then electric circuits, most of that is in grade 11, but remember there's also a part in grade 12, right? In grade 12, you've got internal resistance. Now, at some schools, or a lot of schools, you already do that grade 12 part in grade 11 because the time in matric is so limited that you do internal resistance in grade 11. So wherever you did that, just make sure that you have it and that you are studying it for your exam. Right, and then we get to electrodynamics. That's the motors and the generators and also alternating current, right? Alternating current. So focus on that. Now, when you look at photoelectric effect and emission, now here, this is 10% of the question paper. And I'm afraid a lot of times when I mark exam questions, the learners seem to have just skipped that topic. So guys, 10%, you can't afford to lose 10% of the paper, right? So go and study this, make sure that you know how to do this. Right, now I've studied, I know all my topics, I am in the exam hall, and now I have to do this. Now, when you are writing this, and there's calculations, you need to know that for every calculation, you need an equation from the information sheet, right? Then a substitution, and then the answer, and it needs a unit, and very specifically 2 places after the comma. In the instructions at the beginning of that exam paper, they are very strict. They tell you that you need a minimum of 2. So you can have more, but you need at least 2. Right. Now, if we've got a question where they gave us the power and the energy, and they asked us to calculate the time, then you would have had a 3-mark question. Right. Now, if I do that and I substitute right, but I forget to put that second place, then I'm losing that mark, right? So I still have that and that, but because I didn't have 2 places after the comma, they might just give me 2 out of 3. So if the instructions tell you to put 2, you have to put 2 places after the comma, right? Now, what some of you like to do is you want to rewrite that equation to have delta T in front. Guys, this is not a wise decision, because if you make a mistake with that manipulation, then it means you are writing down a wrong equation. It's not one that's on the information sheet, and you will have 0, right? So don't go rewriting. Write it the way that is on the information sheet, substitute, and then manipulate it to get the unknown, right? Now, what will happen when I don't write the equation? Well, if you don't write the equation, then you don't get the mark for the equation. That's easy enough. Right, next up. If I don't know what to do, sometimes you've got learners who don't know what to do, and they just know it's all about power and energy, and they write down the equation. That equation on its own is not going to earn you marks. That is a 0, right? If you at least substitute in there, and if the substitution is correct, then at least you have 2 out of 3, even if you haven't worked out the answer. Or even if your substitution is wrong, you will still get the mark for that equation. So don't just write the equation, substitute as well, even if you're not quite sure exactly what should go where. The only thing that you are not supposed to do is just take any old values, right? Then they are definitely going to give you 0. It must be at least be values that were used in the question, right? Don't just go with taking any random number and putting it in there, right? You need to have at least something from the question, even if you are not exactly at the right place, right? So guys, this is physics. I can continue like this for hours, but I'm sure you want to go and study. So I'll leave you now, and then in the next video, we'll talk about chemistry.